Okay, shall we start? Measure of courtesies we won't discuss. Measure of courtesies. What will be? Right. What is meant by measure of courtesies? When we construct your frequency curve, you construct your frequency curve is having high peakness, or whether it is having less peakness, or in between. That decision we can take by using courtesies. You can test the normality of your data set as well. Normal. There are three types of courtesies: leptocourtic, platycourtic, and mesocourtic. You want to determine the type of courtesies by using measure of courtesies. Distribution. The other two, not normal, high peakness than less peakness. In the practical world, we can see according to the types of data, some financial data most probably may be high peakness, leptocourtic. When you probably it may be platycourtic. In between, the mesocourtic is an hypothetical one. Right. First, we write down the measure of courtesies. Peakness of the distribution. Peakness. Peakness of the distribution is explained by measure of courtesies. Measure of courtesies. Frequency curve may be having frequency curve may be having high peakness, less peakness, high peakness, less peakness, or in between. According to the peakness, courtesies can be classified. As follows. First one, leptocourtic. Second one, platycourtic. Third one, mesocourtic. One by one we discuss. First we take leptocourtic. If there is a high peakness to the frequency curve, if there is a high weakness to the frequency curve, there is a high weakness to the frequency curve that is called leptokurtic. In relation to time series data, frequently we can see leptokurtic. Frequently we can see leptokurtic. As an example, stock price of a company. Stock price of a company. Stock price of a company. Right. If you take days, 1, 2, 3, 4, 5 days, stock price may be small changes. 10 rupees, 9.50 rupees, like this. Yeah. Okay. Small changes. Small changes. Then what happened later 30, when you calculate the mean value, deviation is less. Right? Now for the right. When we have a leptokurtic, many data points are mean that therefore deviation will be less. Therefore deviation will be less. Because when you take to a distribution high peak to a mean value, then data points are close to the mean value. The points here. If you take second flat, what would happen? This is flat. Therefore, deviation is more. Right. From that we can study. Right. First, right. Note down like that. High peaks. High peaks. This high peaks. Now we take platinum. In the peakness of frequency curve, is less. That is called plateauing. many data points are deviating from the mean value. In cross-sectional data, frequently we can see plateauing. Example, income of 5 companies. The deviation is high. Why? If you take company and income, first company, second, third, fourth income. Second company sometimes maybe 20 million. This may be 450 million different, right? 50 million, 10 million. Therefore, what happens when you take many data points, we can see these extreme deviations. Here, deviations. That is the normal distribution weakness we expect. Not high, not less, in between hypothetical or measure quantity. If the peakness of the frequency curve is between the lepto and platykurtis, that is called mesocurtic. Between the lepto and platykurtis, that is called mesocurtic. This is the peakness of the normal distribution. This is the peakness of the normal distribution. Right, now you can consider that is measure curve. Right, how you can determine this lepto plateau measure? We want to calculate coefficient of curtic. Using coefficient of curtic, you can identify the types of the cortices, right? Coefficient of curtic. Coefficient of curtic. Coefficient of curtic. Right. Weakness of the distribution. Weakness of the distribution can be determined by a coefficient that is called, coefficient of cutting. It is given below. Right, coefficient of cutting rate semi-interquartile rate divided by P90 minus P10. 10 percentiles minus 10 percentile. Semi-interquartile rate Q3 minus Q1 divided by 2. Okay, am I correct? Right. You are all right. Divided by P90 minus P10. Semi-interquartile rate divided by P90 minus P10. Right. If you got the values like this, if I take this as K30, if you K 0.263, that is called mesocardium. If the value is more than 0.263, that is called leptocardium. If the value is less than 0.263, that is called platycardium. That is the decision. Standard value 0.263. More than that, lepto. Less than that, when you start your research, further you will of kernels. Based on that, further you can develop your decision. But at the moment you want to understand this one. 0.263, mesocardic, more than that, leptocardic, less than that, platycardic. Right? Lepto, meso, platy. Leptocardic, mesocardic, platycardic. Right, now we want to calculate. You have done in this group frequency distribution all these. Okay. What is your first quartile you got? Second quartile, P90, P10. What are the values? You have calculated in group frequency distribution. Later. Semi-interquartile range also you calculated. Q1 and Q3. Q1 and Q3. Range we calculated, mean deviation, then percentiles. P90, what is the value? $70.90.5. P10, 31.5. Then you calculate it 4 times, Q1 and Q3. Q1 and Q3. Semi-interquartile range also you calculate. What is the Q3? 35. 35. It may be a set of observation. Now P10 31.5 in Q3 means P75. P75. But in group frequency distribution take. Q3 should be more than. Just the value is correct. What is the value? 70. 70. 67. 67.38. Q1. Right. In design, I'm going to calculate vertices. Semi-interquartile range minus 42.3 divided by 2. Then divided by 79.5 minus 31.5. Here 5, then 2, 5, divided by 2. Three, 4. Right. Decide the calculation. The interquartile range also you have calculated at the moment 25.5. No need to waste time. Can do. That value divided by 48, 0.265. Three decimal points is sufficient. 0.265. Now take the decision. Distribution is having left occurring. Value is more than that. Now we take decision. Is having a left occurring. Right. Later you will compare absolute value by using standard error of courtesy. For that purpose, you want to study inferential statistics, right? Therefore, at the moment you want to take decision based on that. In your research, you consider standard error aspect, not now. But now take decision. Right. That is the decision with regard to coefficient of Kurtic, measure of Kurtis twins. Now practice this question. Your descriptive statistic, if you practice this one, that is the end of descriptive statistics. Measure of dispersion, measure of skewness, measure of Kurtis, right? What more? No. You want to learn only this, right? Right now, practice this question. Use the following frequency distribution given 31, 35, 36, 40 like that. You need to calculate mean, median, and mode, variance, standard deviation, and coefficient of variance, third quartiles and 90th percentiles, skewness and vertices. All these you have to calculate. Right. Now we start. If you practice this question fully, you will be aware of your discrete viscosity calculations. By next week, I will send an assignment as well. That is the homework assignment. Right, homework means where you are, there you can do that. Right, even though you are staying in hostel, that is a hostel work. Do homework. Frequency 31, 35. Six. A plus 4. 1 to 45. 46 basically. Okay, 1 is 5. Right, 31, 35, 10 plus 7. Four, 5. Sigma F point. Right. All right, 40. Calculate mean value x bar. I use assume mean method. A plus sigma f d over sigma f. Right, whatever the formula you like, you can do. I use assume mean method. Now the formula means that formula should be used to calculate the mean. Mean calculate for gonna formula. I use assume mean method. First I take the big value. 4 divided by 2. Then at the lower limit 33, 38, 43, 48, 53. Big value. I got the gap. Gap is divided by. Right. Suppose that I think highest frequency 8, therefore mode class is this one. I take that as 8. What you like, you can. This D, if I remind again, X subtract A. Therefore, this Assume mean 43 minus itself means 0. 38 minus 43 minus 5. The values. 48 minus 43 plus 5 plus 10 plus 50, like that you can see. From the class width, it will be deviated. In the formula, A is there, D of FD, therefore multiply F by D. Multiply. 4 into minus 10 minus 40 minus 15, 0, 30, 15, that is 75. 25 to left, 5, 75. Now I take sigma FD minus 55 plus 5, 7, 10, 14, 145. Sigma FD is 90. According to my formula, A I assume as 43, sigma FD 90, sigma F 30, 0, 0, that is calculated 43. Next I calculated 40. Okay. X bar 43. 46. 46. 46. Right. Now we start the next calculation.
Excuse me, sir.
The second one, median. 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 How you decide the location? First I take location. Right. It is. Right. Now I calculate location. N means 30. 30 divided by 50. 15th observation is the median. 15th observation is the median, isn't it? 30 divided by 2, 50. Okay. Now 15th, where it is located? Then it will be easy. First 4, then 3, 7, 6, 21, 4, 25, 5, 30. That is my cumulative cost. No need to take exactly that column here, but even though you calculated here, no problem. Column wise calculating analysis. Enough 7, not enough 50, yes, in this class. Therefore, you obtain your median class. Median class 41, 41. 41, 45. Formula, calculate median now. How you calculate your median? L1 plus n over 2, that is your location, minus the pi cumulative frequency after that multiplied by class width. L1 41, 45 class lower real limit subtract 0.5, 40.5. N over 2 we know 15. Up to that, this is the class. Up to that means to the end of the preceding class, cumulative frequency 7. Fm means frequency of the median class 41, 48, median class frequency is 8. Class with C. Difference of the real limit 40.5, 45.5 class width is 5. This is P class width 5 multiplied by 5. Right, 40.5, 15, 7, that is 8 over 8 multiplied by 5 is set out 545.5. Median 45.5. Why 45.5? 15 you need, 15 available, therefore that is the end of the class. 45.5. 15 you need, 15 required, that is 15 required, 15 away. That is only material. Then upper real limit. When we take the formula, we can see. Next one, mode. Now calculate mode. Mode L1 plus delta 1 over delta 1 plus delta 2 multiplied by C. Mode class is the highest frequency 8, therefore lower real limit 40.5. Delta 1, difference of the frequency between mode class and low class, 8 minus 3, 5. Delta 1, 5. Delta 6, 2. Class width we know 5. Now simplify. 40.5 plus 25 over 7. 45. 47. Fine. 7 into 3, 21, 4 left, 40 means 535. Then 0, maybe number of decimal, but I take one decimal point. 0, 10, 4. Otherwise 44.0 something you will take. Right, we finish mean, median and mode. Now calculate variance. Sigma square, sigma minus sigma f d over sigma f total square. We use that formula. Right, all these formula I think that you remember, right? You know. Practice, when you practice, you will become familiar. Sigma FP already we have taken sigma FD 90. You need to calculate only this part. First take D square part. After that calculate FD square. Square of the difference. D square, 100, 5 square, 25, 0 square, 0. 15 is square to 25. Now calculate FD 4 into 100, 400. 3, 25, 75. 6 into 5, 33 left, 12, 15, 150. Two left, 10, 12, 1 left, 10, 11, 1125. Now take summation of that. By using your calculator, you can quickly calculate. 10, 1 left, 15, 1 left, 5, 7, 8, 7, 15, 1. 2, 8, 5, 0. 2, 1. I have 27, 2, 150. Right, 2, 150, 2150. Now substitute 2150 divided by 30 minus sigma FD 90 over 30 and square. 0, 0, 7, then 1, 20 means 2, 60. 20. 7, 1, 10, 20 means 2, 6, 3, 6, 18. Right, by using the calculator, I do that. 71.6, 31.6. Nice. Minus 9. Variance 62.6. Take my step. 62. Deviation means square root of that. You know, square root of 62.6 is called standard deviation. Now I take square root of that, 7.91. Coefficient of variance. Coefficient of variance is standard deviation divided by mean value multiplied by 100. mean value 46 multiplied by 100. $17.19. Coefficient of variance 17.19 as a percentage. Third quartile and 90th percentile. I delete, take this space. Right, Q3 I want. Third quartile. Instead of third quartile, I correctly 75. Formula, percentile formula N1 plus P into N minus capital F over simple F multiplied by C. This is your location, P into N. Now I calculate location P into N. 75 means 75 over 100. N means 30. $75 into 30 divided by 100. 22.5 I need. 22.5. To use calculator to save the time, right? We are 22.5. You have cumulative frequency. From that I identify. I take cumulative frequency because I take it right. 4, 7, 8, 15, 6, 21, 25, and we are 22.5 each. Oh no, 7, no, 55, 15, no, 21, not enough. 25, finish your class should be this one. Should be this one. 155. Then I calculate my Q3, that is P75, L1 50.5 lower real limit. Capital F cumulative frequency up to, that is the end of the preceding 21. Always this value should be less than this. Divided. Simple F. Frequency of the percentile class 4. 4. Now simplify. That is your third quartile. Third quartile. 22.5 minus. You need to multiply it by 5 as well, divided by 4. Then you need to add 50.5. 52.37. 52.37. 2.37. Or 38, no problem. 52.37. Otherwise, 52.3. or 4. Right, that is Q3. P percentile. Take P90. P9. P9. Location 90 over 100 into 30. 0, 0, 0, 0, 27. It belongs to last one here. This class. 27, 9. If it is in the final, 56, 60 class. Then use the same formula. $55.5. P20 we know 27. Up to that means 25. Frequency of the class 5, class width also 5. And 5 set off here 2. Then 57.5. P90 57.5. 57.5. P9. Right, then calculate skewness and curtices. Skewness. Take decision by using skewness. I use first one, mean minus mode, divided by standard deviation. If you like, mean minus median multiplied by 3 divided by standard deviation. Two formulas you know are here. You know are here. Right, is the problem here? No?
Excuse me, sir. Excuse me, sir. Excuse me, sir.
Yes, sir.
Excuse me, sir.
Now it's okay. That's all. But that's why. Right, but the previous day, this camera was that type, that area. Therefore, it will be better, but really it is difficult. Otherwise, you can scan whatever you have written and circulate with your friends. Right, then we want to study, we want to calculate skewness. Mean value 46 minus mod 44 divided by standard deviation 7.91. I use first formula. Okay, divided by 7.9. 0.252. 0.25. If you like, you can use the second formula as well. What is the second formula? Skewness we calculated mean multiplied by 3 divided by standard deviation. No problem. You can use that formula also. Right, using first formula when you calculate, you obtain 0.252. What is your decision? Theta, normal or not normal? What is the range? Minus 0.5 to plus 0.5 normal. Up to minus 1 and plus 1, moderately skewed to approximately normal. Beyond that, not normal. Now here, 0.252. Normal or not normal? What happened? No problem. 0.52 plus 0.5 normal. This is 0.2. Therefore, you can say distribution is normal. That is your interpretation you want to write. Is skewness after the calculation. Distribution is normal. Otherwise, your data are normally distributed. My 0.52. Right. Next one. Calculate currencies. Right. Calculate currencies. Right. I informed it by this camera is not installed. It's not talking. How you calculate currencies? We know Q3 minus Q1 divided by 2 semi-interpotile range divided by P90 minus P. Q3 is 52.37. Q1, no, you need to calculate. P90 you have calculated, P10 not yet. Q1 you need to calculate. Q1 means P25. Percentile formula you use 25 over 100 into 25 over 100 into 30 out of 30. How much? 0, 0, 7.5. 75 divided 7.5. 4 not enough, 7 not enough. If it is this class, 41, 45. Lower limit 40. P 27.5. Up to that means preceding 7. 41, 45. Frequency is 8 plus 5. That is my Q1. I calculate Q1. Right. Point 5, 2.5, 2.5 over 8 plus 40.8. 40.8. Answer is 40.8. You need to calculate last one, P10. Calculate P10 as well. P10. Right, percentile formula, do that. P10. Location 10 over 100 into 30. 3. It is located in the first class. Here. P10. Lower year limit 30.5. 10. 3. Capital F preceding class, no preceding means 0. Frequency of the class is 4. Class with 5. Right, 3 minus 0, 3, 3 to 5, 15, 15 over 4. Answer is 34.2. 30. 34.2. Or 2 over 1 decimal point you can. Right, now courtesy Q3 52.40.8 divided by 2. That value divided by B90, 57.5 minus B10. That's the answer. Right, now 52.37 minus 40.8 divided by 2, the value. I 57.5 minus 34.25. 0.248. 0.248. Right? Right, you got the answer. After I got. Or before that? Before that. Now, 263 standard value, right? Less than that. 0.248 our answer. Therefore, distribution is having practicality. Right. Now we can write interpretation. Coefficient of chaotic case. Coefficient of chaotic case less than 0.263. less than 0.263. Therefore, distribution is having therefore distribution is having plateau. Distribution is having plateau. Oh. Right, that is the end of descriptive statistics. I discussed introduction from methods of sampling we pitch, random sampling technique and random sampling technique. We came to data organizing part, right? Data organize, array frequency distributions, ungroup, group and cumulative frequency distributions. Then we presented data, graphical presentation, histogram, frequency polygon, frequency curve, cumulative frequency curve overview. Then I discussed sigma notation. After the sigma notation is started, descriptive statistic, measure of central tendency, measure of dispersion noise skewness, measure of courtesies, measure of skewness, measure of courtesies, right? Measure of dispersion or the variance. Then you completely study descriptive statistics. Then in your research, you can test normality of data, and also you can identify the nature of data, nature of variable, nature of response, what is the business nature, in average, what is the value, how far it is deviating, the standard deviation, whether the data set is normal or not normal, what is the bigness, all these decisions you can take. Okay. Right, then we want to start inferential statistic part. In the inferential statistic part, first we take estimation. Right, now take estimation. Estimation. Right, these terms you need to study first. Estimation. අස්තමේන්තු කිරීම, නිමාණය කිරීම, නිමාණය කිරීම, ඇස්තමේන්තු කිරීම, හරි, estimation. Right, estimation. Estimation. Estimation means you are having sample. But you are doing inferencing for population. That's why we say study sample and decision about population, inferential statistics. To understand the nature of data, you have to then sample. Right. Estimation, you need to inference population parameters. This population parameters you estimate. You are using sample statistics you use to inference population parameter, that is called estimation. Estimation. Right. Briefly write down estimation. Inferencing population parameters. In population parameters. Inferencing population parameters. Inference अनुमिति करने का मतलब inference. Inferencing population parameters in sample statistics. Using sample statistics. Using sample statistics is called using sample statistics is called estimation. This belongs to inferential statistics. This belongs to inferential statistics. In the inferential statistics, we use sample to take decision about the population. As an example, test the average weight of a sample, to determine average weight of total production. Average weight of total production. Average weight of total production. Sample quality you test determine average weight you do. What is the average weight? You are testing a sample. Then you take decision about the average weight of the entire productions. Right? Right. Need to study given here parameters and statistics. What is the difference between these two? Right. Then we take some heading parameters and statistics. Parameters and statistics. Right. If we take this statistics and parameters. Sankhyapi paramiti. To calculate for the sample, they are called statistics. The measures you calculate to the population are called parameters. English letters we use for statistic, Greek letters we use for parameters. That is the difference. Statistic English letters, parameters, Greek letters. These calculations for sample. When you take the mean value, X bar we use here. That is population parameter mean is the mu. That is a Greek letter. If you take proportion, samanupati, proportion, we take simple P. Here we use 5. We use here SPR, sum. Here we use Greek letter, simple sigma SPR. S. Here we use simple sigma. Like that, English letters and Greek letters, statistics and parameters. Okay, right. Now we write down statistics and parameters. Measures which are calculated to the sample. Statistics are called statistics. English letters are used to represent measures to the population. Are called parameters. Greek letters are used to represent parameters. Right, example, write down mean, proportion, variance, standard deviation. Proportion. X bar mu. Square is simple sigma. Mean, proportion, variance, standard deviation. Right, some terms we want to study before the calculation. Estimate and estimator. Estimate and estimator. Estimate, nimitiya. Estimator, nimanake. Nimitiya, nimanake. Right, when you are going to calculate, always we take numerical values. Therefore, numerical value that is calculated for sample statistic is called estimate. Numerical value that is calculated to the sample statistic is called estimate. To inference population parameter, which sample statistic you use, that is called estimator. Understood? Numerical value that is calculated to the sample statistic is called estimate. To inference population parameter, you use the sample. Example, you want to inference mu. You calculate x bar. Numerical value of that is 50.2. 50.2 sample status. To inference this mu population parameter, you use sample statistic x bar. This is called estimator. Understood? Right. Numerical value is estimate. Because after this, we are coming to the hypothesis. Where we want to use expected estimate, sample estimate. Otherwise, you can't study hypothesis. Calculate the name. And you need to study hypothesis. Estimate is a numerical value. X bar. X bar is estimator. Right. Now we write down numerical value of sample statistic. Numerical value of sample statistic is called estimate. Is called estimate. Is called estimate. Sample statistic that is used to inference. That is used to inference the population parameter. The population parameter. Estimator. Is called estimator. Sample statistic that is used to inference the population parameter is called estimator. Example. Always write in the example. Example. Inference population mean calculate sample mean. Then sample mean is estimator. Sample mean is estimator. Numerical value is estimate. Numerical value is estimate. Right, further if you want, you can write x bar equals 50.2. This is estimate. This is estimator. The objective to inference mu. So from this you are finally you want to take decision about mu. That's what we do in estimation. Right, then we want to study sample size. Sample size. Sample size. Right, according to the size of the sample, they can be classified as small sample, large sample, like that. Large sample, small sample. If you can apply Z table, Z distribution, Z is you can use. Standard deviation of the population, you can use Z table. Practically, We cannot take population standard deviation. If you have done previous studies for the population, you can find. Otherwise, small sample, we use t-distribution. Use of freedom, we want to use t-distribution. That's why small sample we use t-distribution. T-distribution. Before giving the note, I will show this one. After that, I will provide note. Sample size, large sample, and small sample. Large sample means size of the sample 30 or more. Small means less than 30. If you know large sample, is a table you have. A small sample, again you classify, do you know standard deviation of population? Standard deviation of population is no. No problem. Practically, we can't take standard deviation of population. All the items we don't study. Therefore, standard deviation of population is unknown. T-distribution. Student T-distribution use T-distribution, T-table. Practically, a small sample you apply T, large sample you apply Z. If you know standard deviation of population because you have done previous studies, you have obtained, then you can use Z distribution. Practically, you use T. Okay, that is the sample size you want to use. Right, now we write down sample size. According to the size of the sample, they can be classified as large sample and small sample. Large if the size sample is 30 or more, in bracket write down this symbol 30 or more. That is we apply Z table. We apply Z table. I send these two tables, Z table and T table as well. You got no? Z table का T table का हम लोग you can LMS क्या किया? Estimation this hand of two handouts as well as Z table and T table. कोई ठीक है हम हाथ रख क्यों? रखने दे. हम भी. We apply the table. If the size of sample is less than 30, that is a small sample. Small sample. Even though the sample is small, if we know, or if we have a standard deviation of population. Otherwise, we apply t-table. Otherwise, we apply t-table. Practically, apply t-table. Practically, we apply t-table in the right. Whatever I explain, all these will be represented here. Therefore, you can note down this one. Large sample, small sample, result and a small sample. Further, you can classify standard deviation of population is known, result, unknown, T. T table or T distribution. Because you have to use is a table, T table, and another table you have to learn F table. Your syllabus F table also you. Right, උදාහරණයක් දෙනකොට T table එක. Practically, we want to do that. Because always we don't study population. It takes time. It will be a huge cost. Sometimes we can't study population. I discussed at the beginning. Introduction part. Right. Next, we want to study rules of estimation. Rules of estimation. Rules. Rules of estimation. Demanding need, right? Estimate to be needed, rules of estimation. Right, very statistical regularity. Second one is law of inertia. These two rules, right? Then write down. Following rules are very important. Following rules are very important in estimation. In estimation. Law of statistical regularity. Regularity. Second, law of inertia. Law of inertia. These two rules, very important. You can justify the appropriateness of your sample also by using these. What is meant by that? First, we take law of statistical regularity. Sankhya Saviditaniya. Right, this law says take your sample size, large sample 30 or more, your population parameters can be estimated well. Why you can estimate well? Outliers effect. Outliers. Otherwise, extraordinary items, their effect will be removed because of large sample, 30 or more. Extraordinary items effect can be removed. They can be neutralized. When you are testing by using statistical package also, you can see the same thing. Data will be normally. But you have to select your sample without being biased. Better to use random sampling technique as much as possible. Right? But according to the type of your study, maybe random sampling or not random sampling, but without being biased, take the sample. Right. That is step 5, law of statistics. Now we write down. This law says that. If we select large samples, right, within bracket again, right, in 30. Population parameters. This is because effect of extraordinary items. Activity item, right? Effect of extraordinary items within bracket outliers. outliers के लिए effect of extraordinary items, outliers, right? Can be removed because of large samples. Samples should be selected. Samples should be selected without being biased. Better to use random sampling techniques. Right, in the mga simple random stratified sampling, systematic, classified, multi-stages. Right. Okay. Second, law of inertia. संख्या පිළිබඳ ආවස්තිතික නියමය. law of inertia. Second, විශාල සංඛ්‍යා පිළිබඳ ආවස්තිතික නියමය. law of inertia. Right. This rule is a sub-rule of law of statistical regularity. Make it upeka sub-rule. It is population parameters can be estimated correctly. Why? The variance to upper direction and lower direction. If your parameter is here, this side may be some values may be more than that, positive sides. Some values may be less than that, negative side. They will be set off each. Parameter can be established. That is said by law of inertia, right? The normality we test by using that residuals normality also, right? By using that's right. Now we write down law of inertia. This is a sub-rule of law of statistical regularity. This also says that if we select large samples, population parameters, if you select large samples, can be estimated correctly. can be estimated correctly. This is because where upper direction and lower direction will be set off each other. Various to upper direction and lower direction will be set off each other. The parameter will be established properly. Suppose that your mean is 50, right? Then when you are taking more and more data, upper side values also there may be. For an example, 6 more and more data. Then what happened? 60 minus 50 plus 10. 40 minus 50 minus 10. So like that, they will be set off each other, then parameter can be established. That's why more and more data. That's why when you are doing your research, better to take large samples. Examiners, you are writing reports, so you want to write you are having a thesis at the end dissertation. I know that according to my mind, you are having dissertations. You are writing reports. Otherwise, extended report you write. You are having Viva as well. Viva එකක් එහෙමත් තියෙනව නේද? තිබ්බත් එකයි නැතත් එකයි එහෙමනේ. Right. So then more data, my sample is large. And that's why you are learning these tools and techniques, right? Right, then we want to study normal distribution and standard normal distribution. Right, now we take next subheading, normal distribution and standard normal distribution. Right? Normal distribution and standard normal distribution. Normal distribution and standard normal distribution. Normal distribution means normal we know. If our frequency curve is bell-shaped, that is normal. In the normal distribution, you can see original values, x values. Because when you are collecting data, you are having x. Then those values are transformed into standard value, same distribution. That is the Z score. Advanced level students marks we transform standard normal distribution. How we do that? Original values x value minus x bar divided by standard deviation. That is the Z score we calculate. When we are having this value, center point, you are having mean value x bar. And x bar. The left side you are having values that is less than mean value. When you are transforming x bar then what happened? X is also x bar also same. Then what happened here is a score. X1 is more than x bar. There X2 is less than that. Therefore, negative is a score. Zero means that the student has obtained average mark of the entire students. Right, 50% is there. Positive Z score means that the student has obtained the marks more than the average of entire students. Negative Z score means that the student has obtained the marks less than the average of total students. In original value and Z score, standard value. We have prepared one table zero. We have developed one table. Otherwise, to the original data, if you are going to develop a table, what would happen when x bar is 51 table, 50.1 another table, 50.12 another table? It is impossible. Therefore, always one table, right? Always mean will become zero, right? Therefore, Z table has been developed through this distribution. The Z score, not original value. Original value is transformed into Z score using this formula. Then you can use this table. Okay. If the frequency curve is symmetric, सममितिकार, right? That is the normal distribution. That is the normal distribution. It is having original values. It is having original values. Within bracket x values. Original values. If the original values are form into a standard value. Within bracket is a standard value. Within bracket is a, that is called a standard normal distribution. Standard normal distribution. Z score is calculated by Z equals x minus x bar O standard deviation. Standard deviation. Always mean value. Within bracket x bar. Always mean value. Transform into zero is a disco. Therefore, one table. Within bracket is a table. Has been developed. To the standard normal distribution. To the standard probability is calculated using this table. Using this table. Right. Briefly, you can note down this. This is standard normal distribution. Normal distribution. Take an example we can. That's done. Right. Now we practice with exercise. Right. Example right now. Mean and standard deviation. Mean and standard deviation of a sample. Mean and standard deviation of a sample are respectively 50 and 2.3. Calculate the Z score of 45 and 60. Right. Now I can take mean value 50. 60 means the right side value. 45 means left side value. No. Now calculate Z score of these two. Definitely 50 minus 50 is Z score of 45. Z X is 45. X bar 50 divided by 2.3. That is a negative value. 2.17. Minus 2.17 is a discount. Well, this side positive. I calculate here. Result 60 minus 50 over 2.3. 4.34. That is the cost. Right, using original values, you can calculate is a disco. The disco you can do. Right, now there are attributes of we need to learn clear. Right, then we take attributes of normal distribution. Attributes. or characteristics. Attributes or characteristics. Characteristics of symmetric, samamitikයි. Right. First one. Distribution is symmetric. Distribution is symmetric. Distribution is symmetric. Samamitikයි. Second, it has the bell shape. It has a bell shape. Zero ka hada it has a bell. Next, you can see these two tails are close to x-axis, but they do not touch x-axis. Third one, two tails are close to x-axis. Two tails are close to x-axis, but they do not touch x-axis. But they do not touch x-axis. Fourth one, that when you take that x-axis and this frequency curve, area covered by the frequency curve and x-axis will be 1. From the 0 point right side point 1. That's why we can calculate probability using area. Right. Next one, area covered by frequency curve and x-axis. Frequency curve and x-axis. Frequency curve and x-axis is 1. Is 1. From this 0, right side 0.5, left side 0.5. Quanto vale? Doesn't pass. Wow. That's why we can calculate using. We can calculate probability using area. As you take, that is a probability. That's a probability. Next one, when you are taking standard deviation from the mean, right? One standard deviation from the mean, 68% will be covered. Two standard deviation, 95% will be covered. Three standard deviation, 99% will be covered. That will happen according to the mean value and standard deviation. Right. Next one. Area is explained. Is explained by the frequency curve. By the frequency curve will be as follows. Will be as follows. Right. From mean value, positive and negative, one standard deviation if you got 68% area will be covered. Area. .5% will be covered. From the mean value, if you got that is the area. මේ කලවරණ area එක වර්ගඵලය area. For your purpose, if I draw like that, like this, I take one standard deviation to both sides. That area, this area, 68%. If you got two standard deviation from the mean value minus 2 standard deviation plus 2 standard deviation, that area is that right? That is 95%. Then 3 standard deviation, if you go, that area will be plus 3. That's why confidence is coming. Next one, you can see මධ්‍යයෙන් ඉඳලා දෙපැත්තට එක ස්ටෑන්ඩ් ඩිවිෂන් එකක් වෙනකොට 168යි, දෙකක් වෙනකොට 195යි, තුනක් වෙනකොට 195යි. ආවා. Value we want to take acceptance region, rejection regions like that. Right, next attributes, that is the last one. This type of graph, you know y equals a plus bx, mx plus c. Okay. When you are taking this type of distributions, graph, again the graph is behaving like this, cubic, y equals ax cubed plus bx squared plus cx plus p. Like that you are having this frequency. Normal distribution is having the following function. The following function. But it is having a function y, right? Then you can see standard deviation, square root 2 e to the power minus half. That's function. This is the function, normal function. E to the power of minus half x. It's a disco gun. It's a disco way only. Minus x power standard. It's a disco. Right. But because we are using the table, use the function for the calculation. But for significance value, when you want to calculate in your research, you can use. Right? What is meant by this E? Natural logarithm ln log base. ln log की base account ln E. log log means base. 2.71. Logging 5 decimal. කෙලවරක් නැතුව යනවා. 2.71 ඊට අපි සාමාන්‍ය ආසන්න කරලා මුදුම කැල්කියුලේට් කරනවා. We want to calculate very accurately 15 decimal points we use. දශම ස්ථාන 15 තරම් තමයි calculate කරන්නේ. Wait. 459045 15 decimal. That is the ratio of circumference and the diameter is compared by the path. Right, that is 3.14159265. As Mantan Namaka. Unara Muna calculate color calendar. Computer package again. අපි ඔගේ ආසන්න කරලා කැල්කියුලේට් කරන්නේ 2.718 විතරක් කරා 3.141 විතරක් කරා. Don't want to use this. Why? The table එකේ the table එක තියෙන no need that formula to be used. මේ formula එක පාවිච්චි කරන්නේ නැහැ කියන ප්‍රශ්නයක්. එහෙනම් දුන්නේ ඒක තියෙනවා. formula එක තියෙනවා. Right, the table එක තියෙනවනේ. It's a table එක. It's a table. Therefore no. Okay. මොනවා කල්පනා කරා? වෙච්ච දෙයක් කියලා. Right. Now this is the normal distribution function like mx plus c, x squared plus bx, x again තමයි. That function එක. Standard deviation එකයි mean එකයි තියෙනවා. 2.718 3.14 දාලා simplify කරා. උත්තරේම. Right? හරි. අපි table එකෙන් තමයි study කරන්නේ. 2 more minutes. Right, we can finish today. You are having 11:30 another day. Oh, jadi koik sama sama asal nasi gitu kan train kita lu ada bola ikam season juga. Oh,